Hello and welcome. My name is Unhelkar and I'm presenting to you now the component and deployment diagrams, which are both considered implementation diagrams of the UML. In between, I am also briefly talking about composite structure diagrams. Now, as you will appreciate, until now we used UML to model what the problem was through techniques like use cases and activity diagrams and and high level class diagrams. Then we moved into the solution space and we made use of advanced or detailed class diagrams, sequence diagrams, state machine diagrams. Now all of this is good, but it is still not the actual system. A while ago I must have mentioned that a entire system can be put together as just one class. That's not what we want to do. We want to create many classes based on the way we want the use cases to execute. Each class is a subject area, lower level, and we break it down further. Remember, we discussed granularity, which is the size of a class. So one system can be made up of many smaller size classes and a few large sized classes, or in theory just one class. But because we have got many classes in a system, which are basically self-contained units of program, we need to put all of them together in order to create an executable system. So although not always 100% true, but you can take this as a definition of what is a component. A component is a collection of classes which will execute together cohesively. But again, most modern day systems are not just one system. You will find that they are typically distributed. The interface is working on my computer. The logic could be spread out anywhere, either on my computer or on a server. The backend database might be in the cloud somewhere. Now these are real practical execution level, operational level issues, and we use a component diagram to show that particular executable or a library or a collection of interfaces, and then we show the dependencies between those components. You will find in your case tool for UML, you can create a component icon and you can assign various classes that are realized by that component. So it's a important diagram. It is taking us more towards architecture of a system, and while we don't want to study that in too much detail in this particular course, we still want to be able to appreciate how a system is actually going to function in reality through those executable classes. And then if we want to show the runtime setting of all these components in execution, then we use what is called a composite structure diagram. Composite structure came a little later in the UML. Earlier version 1.4 did not have, 1.1 definitely did not have composite structure diagram. So we want to show runtime situation. What is the composition, what is the structure of these executable entities? So you will be able to study and able to model your final system through these component and composite structure diagrams. Now, because a component is a larger entity and all the classes are sitting inside it, so the component itself is not necessarily object oriented, but all the elements, all the classes that are inside the component are object oriented. So treat the components as your final executables, and because the final executable cannot be or is usually not just one executable but a collection of executables that are spread out, distributed, so you need to give components some more thoughts. And then finally we are talking about the deployment diagrams. When a system is deployed, it is actually going to execute on physical hardware. So out of those 14 UML diagrams, deployment diagram is the one diagram that is incorporating nodes and servers, and it's a hardware diagram if you like. So it is our thinking of how our system is going to be deployed. And so you will find a couple of examples of deployment diagrams, and you can create your own examples as well. And in today's age, with something like a mobile device almost invariably at the end of our system, we might have to include those bits also in our deployment diagram. And these diagrams are obviously kept in the background space because they are not just solution. They need to ensure that the solution actually fits in with the rest of the ecosystem of the organization, the IT environment of the organization. Hence, these are in the background space, and the model that we create is model of background space. So keep these implementation diagrams in mind. They won't take much of OO thinking, but they will definitely require you to give some thought as to which classes will belong to which components and which components will be deployed on which particular node. And some of this you can do in the exercise, and others like actual physical deployment you can't, but you need to give it a thought. And once we have done this, we more or less complete our study of UML, but we need to worry about how our system that is operationalized will be successful. We can't have the best system in the world which is so slow that the user gives up, or which is so insecure that all kind of users can get in, or which is brilliant but does not comply with the legislation. Those are some of the things we will discuss in the subsequent module, and also a bit of chat on quality assurance and testing of these diagrams and what we produce. So take care and keep working on your assignments, and I hope you have enjoyed what I have presented thus far. I have certainly enjoyed presenting it, and only a couple of more modules to go. Okay, take care, bye bye.